So your last example, a skier initially at rest accelerates uniformly down a 75.8 meter slope. The time is 9.3 seconds. What was the speed of the skier at the bottom, and what was the acceleration of the skier? All right, so pretty straightforward, but let's take a look. So we might draw a little bit of a slope here. Here's the skier. All right, and the length of the slope is 75.8 meters. The skier starts initially with an initial velocity of 0 and takes a time of 9.30 seconds to go down. And the question is, what was the what was the speed at the bottom? Well, since initial velocity is 0, since the displacement is 75.8 meters, since the time of flight or time of travel was 9.30 seconds, we want to know what VF is. All right, and of course the equation D equals VF plus VI over 2 times T works for us. We have to solve for VF, and so 2D over T equals VF plus VI. I multiplied both sides by 2 and divided both sides by T, and that left me with VF plus VI. Then I subtract VI from both sides. Well, since VI is 0, 2D over T equals VF. VI is 0, so 2 times 75.8 divided by the time, which was 9.30 seconds, gives us a final velocity at the bottom of 2 times 75.8 divided by 9.3, and you get 16.3 meters per second. 16.3 meters per second. And that's it. All right. You could convert that to kilometers an hour, but there's no need in this particular question. Now, what's the acceleration? Well, acceleration is going to be equal to, if the initial velocity is 0, the time of flight is 9.30 seconds, and the displacement was 75.8 meters, then you could say, well, our equation D equals VIT plus 1/2 AT squared works because the initial velocity is 0. And if it wasn't 0, this could be a bit of a problem. But since D is equal to 1/2 AT squared, then A is equal to 2D over T squared. And that would be 2 times the distance, 75.8 meters, divided by the time of travel, 9.3 seconds squared. Now don't forget to square that. A is equal to, so we get 2 times 75.8 divided by 9.3 squared, and you get 1.7528 meters per second squared. And so you probably round that to 1.75 meters per second squared. That's the acceleration. Now, an alternate method would be to use the final velocity that we calculated in the previous question, or in the previous part of the solution. Since in the first part of the solution we said that VF was equal to 16.3 meters per second, since VI is equal to 0, now we could use D is equal to 75.8 meters and solve for A using the equation that doesn't have time in it. Oops, sorry. We could calculate A using the equation VF squared equals VI squared plus 2AD, and A is equal to VF squared minus VI squared over 2D. And A ends up being equal to 16.3 meters per second minus 0 divided by 2 times the distance, which is 75.8 meters. And what we get, of course, is 16.3 squared divided by 2 times 75.8. And we end up with 1.75 meters per second squared, which is the same as we got using the other method. So there's a number of different ways sometimes you can play. There may even be a third method that you could solve this one by using A is equal to VF minus VI over T. Once you know what T is, you could go 16.3 minus 0 over, and then the acceleration, or sorry, the time was 9.3, so you get 16.3 divided by 9.3, and that gives you also a solution. 16.3 minus divided by 9.3 gives you 1.75. So lots of different ways sometimes to solve this. The fact that you get the same result no matter which way you go, in fact, verifies the process. All right, so those are a bunch of examples for you, and hopefully by looking at these examples you see the process, and now you can put it into practice.